We are here today to talk about packaging and packaging waste regulation, or known in abbreviation as PPWR. Imagine there has been quite a few these webinars already on the topic, and I hope I will be able to present something new and fresh to you, or provide you some valuable insight, especially on matters when it comes to laboratory testing. Of course, the PPWR covers a lot of things, but only a few things are something that, at least for the time being, are require laboratory testing. So specifically, this webinar will be focusing on those parts of the regulation. I realized I didn't introduce myself yet, so my name is Niko Markkinen. I work as a senior testing expert for Measurlabs for a bit over 4 years now, and my area of expertise is food contact materials. For those who are not familiar with Measurlabs, we are a laboratory testing service provider. Our headquarters is in Helsinki, Finland, but we have also hubs in United Kingdom in Cambridge and United States at Palo Alto, California. Our main product, let's say, is laboratory testing services. We provide services to a range of different industries: semiconductors, packaging industry, food industry, etc. But since I imagine most of the people online at the moment are related to the packaging industry, from that point of view, we cover chemical testing, mechanical testing, physical testing. So on the chemical testing side, obviously, things related to PPWR, REACH regulation, food contact regulation, barrier testing for OTR, VVTR, but also recyclability and biodegradability testing. So all sort of things related to packaging. And whenever you see on the slides the simple small Measurlabs logo, that means that the service being referenced is also something we have available. So don't hesitate to reach out afterwards to us in case that's something that you would be needing now or in the near future. So agenda of today, so starting a bit on like a big picture, what is PPWR, who does it concern? Also discuss about like what is packaging from the framework of the regulation, what does manufacturer mean, what are supplier obligations, selected timelines in the near future, but then a deeper dive to certain articles related to sustainability requirements, to which some laboratory testing is looking at the moment being relevant. So, for some of them more urgently, and for some of them more in the future. Obviously ending with conclusions and leaving some time for questions and answers. So PPWR, actually as a concept, is familiar for all of those who are present. So it repeals the old packaging and packaging waste directive. So now it's regulation, and it applies as such directly to each member state. So the idea is to kind of overhaul how we handle packaging waste in the EU to produce more like a circular economy, and so that packaging are easier to recycle, and we start to use more recycled material in the packaging, and at the same time remove harmful substances that would prevent recyclability or cause health hazards to EU members or EU citizens. Who is responsible? In the big picture, everybody who is part of the manufacturing chain is responsible, but from purely regulatory point of view, quote unquote, manufacturer is the one who has to make the DOC and the technical documentation to make sure that packaging, once it enters the market, fulfills the criteria of PPWR. But the whole supply chain needs to support the manufacturer in this endeavor. A few key dates. This is not obviously everything. For example, things related to recycled content, reuse requirements, etc. are not here, but on the scope of today's topic, I have brought forward these specific dates. So roughly 1 year ago, the regulation entered into force, and that started the clock that 18 months from that date, which is next August, the regulation will not enter into force, but start to apply. And in particular, the Article 5 for PFAS and heavy metal limits starts to apply in August, but also basic recycling requirements under Article 6.1 start to apply. A few years from here, the estimation is that January 1st, 2028, but we will see how it turns out in practice, is that the methodology and requirements for recyclability will be adopted. And that starts a clock that within 2 years from that date, packaging manufacturers have to ensure that the packaging they release into market fulfills the recyclability or design to recycling requirements of PPWR. In the meantime, also in 2028 February, there's a requirement for certain packaging that they are compostable starting from that date. 5 years from that date, there will be a requirement that packaging must be recyclable at scale. And in 2038, since initially the grading system will be from A to C, and C is the minimum requirement tentatively in 2030, and in 2038, the minimum requirement will be increased to grade B. So grade C will be essentially banned. Before moving forward, I think it's a good idea to kind of bring forth or draw a picture what is considered packaging in the framework of PPWR, because that's not always kind of intuitive. How is it seen there? So in the big picture, packaging intended to protect, transfer, hold, or present a product or item is considered packaging. But also materials such as stickers or labels on vegetables and fruits, mascara brushes that are part of the container closure. Also in certain scenarios, beverage cups, disposable plates are considered packaging if they are used as service packaging that are filled at the point of sale. However, the same exact product might not be considered packaging, for example, the beverage cup, if it's sold at retail as a standalone product for private use. So it has to be used by a business operator as a service packaging to be part of PPWR. I imagine that most cases, beverage cup sold in supermarkets are also used are not only for the private use. So typically, in those cases, though, the PPWR requirement is also there. But also in a case like for cake dollies, that if it's sold with the cake, the packaging is part of PPWR. But if the cake dolly is sold without the cake, then it's not part of PPWR. Okay, so initially I described, as it's in the regulation, that the manufacturer has the responsibility to draw up the DOC, where they present technical documentation that the packaging that is entering the market complies with PPWR and its articles 5 to 12 in terms of those that are applicable at each time. But who is considered the manufacturer then varies case by case. The rule of thumb is that when you look at the packaging and the branding there, the brand owner in most cases is also the manufacturer. The exception would be that if the brand owner is a micro enterprise and the packaging supplier is located in the same member state, in that scenario, the packaging supplier becomes the manufacturer. But if it's a packaging without any branding details, if it's a general beverage cup from the packaging supplier's catalog, then the packaging supplier is the manufacturer. But if it's let's say like a specifically tailored packaging for the one who uses it as a service packaging, then the filler or the one who is using it as a service packaging becomes the manufacturer. There are also those scenarios considering import and things like that, but unfortunately those are not covered in this table. Okay, so the law says that the responsible is manufacturer and who is considered manufacturer in each case. But then the supplier has their own obligations that are briefly described in Article 16 of PPWR. And in essence, they are required to provide sufficient amount of documentation, including technical documentation, to the manufacturer, that they are able to assess the compliance and formulate the final declaration of conformity, or DOC. What it means exactly right here and now is that the suppliers need to ensure compliance with Article 5 prior to the August deadline. When preparation of this webinar, when we had to look the regulation and the different guidelines and interpretation of those guidelines, the regulation, we came to the conclusion that it's kind of safe to assume that not every supplier in the manufacturing chain by default is expected to do the testing, like that everybody from granulate to the final converted packaging with printing inks and paperboard and adhesives and et cetera, would have to repeat the same testing kind of over and over. But it's each supplier from each kind of branch of that manufacturing chain that makes their own judgment call, like how much information I have available. Is it enough to kind of cover my own due diligence that I don't have to do the testing separately? Obviously, from common sense point of view, you think that, okay, we are not adding any PFAS here. Our supplier says that they are not adding any PFAS, and the other ones on the upstream say that they're not adding any PFAS. But so it kind of makes sense that why we need to do the testing. But from how we see it, is that it's unlikely that this type of approach alone would be sufficient to ensure the Article 5 compliance. It's not like set in stone, but this is to the conclusions we have come with, and it seems to be like that. So, but as I said, not everybody has to be testing. So finding a meaningful, compromise in each case makes the most sense. So you evaluate on a case-by-case basis. So, but if you rely on a test report, let's say from a granulate supplier, you make plastic film and you don't add pigments or any other additives that would kind of elevate the risk of PFAS or heavy metals being present. So you rely on the total fluorine results and heavy metal results from your granulate supplier. Okay, fine, but you then have to make that original test report of the granulate then available for the manufacturer, so they are able to use that to make the DOC. However, from the regulatory point of view, the manufacturer has to make the call, looking at the big picture, if the available documentation and test reports are sufficient to ensure compliance with PPWR. Okay, so then that's about the manufacturer, suppliers, and their requirements and due diligence. So next we will dive deeper into 3 specific articles, and Article 5 is definitely something that we will discuss the longest today. So what is the whole aim of Article 5? To kind of summarize what its intent is, to minimize the content of harmful substances in packaging and packaging materials that would have negative impact on chemical safety or have negative impact on reuse or recyclability. So for the time being, there are basically 2 key requirements that are specifically determined. So the restriction regarding heavy metals and restrictions regarding PFAS. There is also, which is not explicitly a restriction, but it just says that minimizing presence of harmful substances in packaging should be minimized, but it's not kind of any tangible or meaningful that kind of points you to any specific testing. But in any case, more detail about the restrictions related to heavy metals. This is something that already existed in the packaging and packaging waste directive, meaning that the sum of lead, cadmium, mercury, and hexavalent chromium must not exceed 100 ppm. This applies to all types of packaging, not only food, but others, but glass packaging is exempted. Under the Packaging and Packaging Waste Directive, the reference method was the one mentioned here. However, this standard has been since withdrawn. Under PPWR, for the time being, there is no kind of specific reference method, but in the Article 35, it says that reliable, accurate, and reproducible state-of-the-art methods shall be used. And when you look at the big picture of doing this type of analysis from a range of different packaging materials, ICP-MS after acid digestion is definitely the key method that is being used at the moment. But for certain scenarios or certain laboratories, packaging materials containing metallic components might be an issue. So in those cases, using XRF could be a secondary option if ICP-MS is not possible. Then moving on to the requirements related to PFAS, which I think this will be one of the most interesting topics to you today, I assume. The requirements under Article 5 is that food contact packaging is not compliant if it exceeds 25 parts per billion of any single non-polymeric PFAS, or as the sum of 250 parts per billion for some of non-polymeric PFAS. But since there are so many different PFASs out there, it's not practical to cover them only by targeted testing there. So there's also this bulk threshold limit for total fluorine, and which is it's a threshold limit, so it's not a compliance limit, basically meaning that if you exceed it, it doesn't lead to automatic non-compliance. The deadline is August 12, 2026, without any kind of a transition period, meaning that manufacturers that place packaging into the market after that date has to comply with these requirements. And recently it has been specified that this requirement under Article 5 doesn't apply only to intentionally used PFAS, but also contaminant or PFAS present as NIAS, for example, from recycled paper. However, at the moment, the suggestion is to use so-called three-step tiered approach, which starts from total fluorine analysis. And if the total fluorine is below 50 parts per million, then it's considered compliant with the requirement without needing to do further testing, even if there are the specific restrictions for substance level PFAS. However, if the total fluorine exceeds 50 ppm, there is a requirement for burden of proof. So you have to show that this fluorine doesn't come from organic sources. So in the next step, it should be shown that the total organic fluorine is less than 50 ppm. And methods such as pyrolysis GCMS has been suggested to do this. And if this doesn't prove satisfactory results, either technical issues or inconclusive results, or having a result over 50 ppm, then you have to go for targeted analysis to show that there is no PFAS present as contaminants. It is also recommended to apply so-called direct top assay in the PFAS analysis to release precursors prior to the analysis. And this top assay will be discussed more in detail in the next few slides. But before moving forward with that, I will go over each method in a bit more detail. So first about the total fluorine analysis and what does it actually mean. So as the word says, total fluorine, it measures the sum of all fluorine, and it doesn't matter if it's from organic or inorganic source. And the main proposed method is combustion chromatography, in which the sample is combusted over at or temperature over 1,000 degrees, which volatilizes all fluorine. That's captured with an aqueous medium typically and analyzed with ion chromatography. And there is a reference method being developed to our understanding to show compliance with PPWR, but typically in different PFAS related guidelines, these standards listed here are being referenced. The challenges with the total fluorine analysis, one is the reporting limit, which is typically depending from laboratory around 5 parts per million. And it's a challenge from that point of view that it's not sufficient to show compliance with the substance level PFAS compliance. So that's why you need to analyze those separately. And also as it reports, it's not able to distinguish between different fluoride types. So if you have inorganic fluoride source in the sample, you might get false positive for PFAS, or you just don't know if it's organic or inorganic. And also often, if the sample contains, for example, alu barrier, that can be an issue for laboratory to do this analysis. Here is just a few references on which total fluorine method is being referenced in different guidelines or regulations. As I mentioned, for PPWR is under development, but these same standards are pretty consistently being referred. Often this documentation relates to evaluating compliance for footwear, textiles, clothing industry, etc. But for example, the Temanor document is like it's a guideline for analysis of PFAS from various different matrices. And so in a case where the total fluorine exceeds 50 ppm, then you need to move forward and gather data to show that if you know or you suspect that there cannot be organic fluorine in my sample or in my packaging material, but I need to show somehow that it's something else. And there are several options to do it. The one suggested at the moment or being specifically mentioned is the pyrolysis GCMS, where the combusted sample generates in the GCMS as a sort of fingerprint. And by looking at this fingerprint, it's possible to distinguish if there are indications for presence of organofluorine substances or not. The challenge is that it doesn't produce kind of like a specific number, like total fluorine is this number, or the content of these substances, this like in LC-MS analysis, but it's a very complicated data set, and that requires a lot of high level of specified knowledge to do the evaluation. The next option would be to extract the inorganic fluorides with some type of hydrophilic medium. And the idea there would be to extract the inorganic fluorides from the sample. And by analyzing the total fluorine and extracting the inorganic fluorides and getting that value, subtracting those from one another, you have a value for total organic fluoride. The challenge is that, which is seen in research, and we have seen it in practice as well, is that sometimes the extraction is not effective for one reason or another to remove, or just extract the fluoride from the sample, and then the result for the inorganic fluoride is underestimated, and vice versa, you overestimate the presence of organic fluoride. Second option, which would be the kind of same approach but from a different point of view, instead of trying to extract inorganic fluorides, you extract organic fluorine substances with a solvent like methanol, and then that methanol is analyzed with compostability chromatography. But the challenge here is that polymeric PFAS are difficult to extract this way, so you have an underestimation of organic fluoride. And then the fourth option would be pre-combustion of the sample or ashing the sample, in effect, which starts with the same approach as for the where the inorganic fluorides are being extracted. So you get the total fluorine value with combustion chromatography. But you also analyze the sample by burning it at roughly between 500 and 600 degrees. So the temperature is significantly lower than in the CIC. So the goal there is that everything organic is being burned away, and the leftover ash contains all the inorganic fluorides. And then that ash is analyzed with CIC, and then you get total inorganic fluorides. And again, subtracting these from one another, you get total organic fluoride. This is also has its own challenges. If some of the inorganic salts are volatilized at the combustion temperature, then you have overestimation of organic fluoride. But if there is some thermostable organ or PFAS present, which doesn't combust during the burn or combusting of the sample, then you basically have underestimation of the organic fluoride because it still remains in the ash. Okay, so those were the options. I assume that there are various other options also for analyzing the organic fluoride, so I'm not saying that there was an exhaustive list, but those are the ones that we have mostly worked with. And then about PFAS on a substance level testing, and I want to specify that one way to distinguish between different types of PFAS, especially because this distinction is made in the PPWR, is that when we talk about non-polymeric PFAS is this. So polymeric, obviously, it's a very long chain of fluorocarbon, but these non-polymeric substances are obviously much smaller, and then those can be then distinguished into possibly two different groups. So perfluoroalkyl substances, meaning that every carbon is saturated with fluoride, or polyfluoroalkyl substances that you might have some aliphatic chains in between, for example. Also, the targeted PFAS analysis can be done in several ways, and the main distinctions or the main methods basically are liquid chromatographic method and gas chromatographic method. And the reason to go with these two approaches is that they are able or they are better suited for different type of substances. LC-based methods are best for ionic, non-volatile, polar, non-polymeric PFAS, while GC, MS-based methods are best for volatile and semi-volatile, neutral, non-polymeric PFAS. And depending on the method used, there are different references available, which are listed here. And typically, the extraction is done either with methanol or alkaline methanol. There is also one method for analysis of plastics, where the plastics are dissolved with tetrahydrofuran and then precipitated with methanol to have a more thorough extraction of PFAS from let's say like a very solid plastic matrix. And this is also something that is commonly used in at least phthalate analysis. Top assay is a bit different. In top assay, typically something that it's done like two analyses are done at the same time. So one is which would be typical solvent or alkaline solvent extraction, followed by LCMS or HRMS analysis, but also oxidation step is being done, and that can be done either before or after the extraction, meaning that the oxidation target is the packaging material itself or the extract of the packaging material. And the guidelines recommend doing direct top assay, meaning that the oxidation is prior to the extraction and not to the extraction itself. And most likely the idea there is that the precursors are converted already in the sample, but perhaps I will go through this more in detail once the slide comes about top assay. But before discussing that in more detail, the challenges of the targeted analysis, which was already referenced earlier, is that there is a huge range of different PFAS that can be potentially used or that can be potentially manufactured, while typical screening method analyzes 50 to 60 substances. At the same time, there is a lack of harmonized methods. Mostly the standardized methods are available or they have been validated and designed for textiles and leather, but packaging can be made from all sort of different materials and combination of these materials. So there's a risk of matrix interferences. Also, there are some particular analysis when it comes to fluorotelomers. We often see that the reporting limit for example, fluorotelomer alcohols is over the PPWR limit, so that data is difficult to use for compliance assessment purposes. It is also a potential issue that the methanol produces esters with these alcohols, for example, and some reports have stated that the alkaline methanol extraction is not optimal for neutral PFAS. But then a bit more about the top assay, and the idea there, in a sense, is to convert polymeric and non-polymeric precursors that have the potential to convert into PFAS to be detectable with the LCMS or LCMS analysis. And the idea is there to simulate conversion of PFAS in the environment, because you mightn't see PFOA in the sample itself, but some precursors, once they enter the environment, over time, via oxidation, they convert into PFOA, which is very harmful substance to various organisms. And as I mentioned before, the oxidation can be done either before or after the extraction, and the direct top assay, being the oxidation before extraction, is the one being recommended at the moment. I realize I'm falling behind with schedule, so I will pick up a speed a bit. So, maybe just describe the challenge for oxidation before extraction, because that's the one that's being recommended. And the only issue there that has been brought up that I've seen is that if the sample contains a lot of organic material that consumes the oxidizing agent, that could lead incomplete oxidation of the sample. So in case some PFAS would be there, they would not be fully converted to the final stable end product. And at the same time, there is a lack of standardization, so there's a lot of lab-to-lab variability how this analysis is conducted. And to end with the discussion with Article 5, ECHA, with the help of, or ECHA will help European Commission to prepare a report about substances of concern in packaging. And this is due by the end of the year. So the idea is to identify what other substances of concern might be present in packaging materials that would compromise chemical safety or hinder reuse or recyclability. Then about recyclability, and that's basically compromises three main points, being the part number 1 or 6.1, that all packaging placed on the market shall be recyclable, and that applies from August. Second part being that packaging should be designed for recycling, and that was discussed earlier, that the current deadline for that would be 2030. And then the last would be packaging is recyclable at scale, and that's the tentative deadline is 2035. The requirement that packaging shall be recyclable, which applies now from August, is basically the same that already applied in Packaging and Packaging Waste Directive. So it's not the same thing as the one deadline that is coming in 2030. So that is basically, in that point of view, nothing new, since it's the same that was already required before. So about the design for recycling, as mentioned, the deadline is in 2030. And the dates now is being set January 1st, 2028, and the second date where you have to comply January 1st, 2030. The 2030 limit can fluctuate if the first deadline is being met. So if the requirements and methodology is not available in January 1st, then the actual date where the recycling requirements have to be met will be 24 months after adoption. In the meantime, there is no need to perform conformity assessment with this requirement until the requirements and methodology is available. And then there will be this ABC grading system be adopted. And initially, minimum C requirement by the deadline that 2030 is required. And in the meantime, while the harmonized requirements are not available, there are some industry guidelines available. Just a few examples to mention here, but will not go further into detail in this webinar. And then the final topic is about the Article 9 and the compostability. And so the selected packaging formats must be designed for composting by 18th of February 2028. And this would be like material for tea bags or sticky labels that adhere to fruits and vegetables. The baseline requirement is industrial compostability, meaning that it can be disposed with the bio-waste that is being municipally collected. There are here some flux. So member states are allowed to request increasing the scope for this requirement, and the deadline for that is also this August. The standards for evaluating industrial and home composting are pending. For industrial composting, standard EN 1343.2 functions as the interim reference. But for home composting, there is no harmonized EU standard available as far as we know. So manufacturers can rely on existing standard and certification schemes. However, in this case, it's important to note that adherence with these interim options doesn't guarantee compliance with the harmonized options once they become available. So to conclude this webinar today, obviously August 12, 2026 is an important deadline. That compliance with Article 5 will be required for basically minimally total fluorine and heavy metal testing being done So you have the test reports, you have the technical documentation provided with the manufacturer, so they can do the DOC. For the other parts, especially with the PFAS testing, the lack of harmonized methods are a challenge for organic fluoride and targeted PFAS analysis. But at the same time, if the packaging material has total fluorine that goes over the threshold of 50 parts per million, there is no kind of option because the deadline is closing in, and of course we're happy to support with the best of our technical knowledge on how to tackle those situations. The substance of concern will be possibly updated at the end of 2026, and then we see if that will have some impact on the regulation also in the future, if other substances will be included in the testing schemes. Recyclability methods and requirements will be available by 2028, and then the recyclability or adherence to these requirements will be required within 2 years after the methods and requirements are made available. And finally, selected packaging formats must be designed for composting by February 12th, 2028. Just quick. What time is it? So the tests that we are able to provide were already marked on the way, but quickly also wanted to mention that we also are able to provide a range of different migration and contaminant testing for packaging materials, single-use and reuse materials, both. So if any of those is something that you need, don't hesitate to reach out. Thank you for your attention, and now it's time for the question.
Yes, we have good time, good 15 minutes for questions. So I think we are well in schedule, even if we had a lot of information to share here. We have already a few questions, so I will ask with those, and if more comes up, keep posting them in the chat, and I will pick them up and we will go through as much as we have time for. So let's start with a few questions related to PFAS, because that is a topic that raises a lot of questions. So the first question is about packaging that is not food contact packaging. So for example, cosmetics and home products. What kind of PFAS testing should be done for those, or is it necessary at all?
The way I read the regulation, I understand it, it's not necessary for cosmetics or household chemical packaging. I think the kind of I understand where the question is coming from, because it's very often that for these packaging materials, the regulatory reference for chemical safety comes from food contact regulation, right? But here in the PPWR, the scope is that specifically for food packaging. So if it's for cosmetics, I don't see, even I'm not a lawyer, but I am pretty confident to say that the requirements doesn't apply.
Yes. Then more about the testing needs. So if a company has an updated declaration of compliance from the raw material suppliers, including the total fluorine being under the 50 ppm limit, sorry, and a report that PFAS is not intentionally added, is that enough, or is some testing still needed?
It's kind of difficult to say on a general level. Like I said, it's kind of, you do case by case evaluation. So mathematically, if you think about it, that if you have component A, B, C, and each of them have total fluorine less than 50, and then you put them together, the combined product should still have less than 50 ppm, because we're talking about mass per mass and not migration, where the shape and size and everything will impact the results. So if you have for each raw material you use, you have this data available, and you're confident, and you know, or you are able to kind of mitigate the risk that there would be transfer of these PFAS in your manufacturing facility in the final article, then I think that you are able to go forward with the documentation alone. But you just have to formulate it in a way that it's still conventional or practical for the manufacturer to use in their own DOC.
Yes. And this goes maybe a little bit beyond the PPWR, but I think it's an interesting question, so I want to raise it up. So if the test shows that the total fluorine is below the 50 ppm level, for example, 30 ppm, can such a material be called PFAS-free?
I don't think so. I think being the PFAS-free statement is something that should be kind of careful about, because this is my reading, how I read the room and read the situation, is that because the lack of harmonization with the organic fluorine and PFAS testing is definitely a bit of a bottleneck. And so my assumption is that this simplified approach might only be temporary, that because the total fluorine testing is pretty problem-free typically, that for the time being, showing compliance, because the timeline is closing in, it will be sufficient. But that doesn't kind of remove the reality that some packaging materials still have the chance to contain PFAS if they don't have to be tested at the moment in the terms of PPWR. So even thinking from a practical point of view, declaring your material PFAS-free would require quite extensive targeted PFAS testing. Only way to kind of be absolutely sure that there's PFAS-free, you would have to have a very, very, very sensitive organofluorine testing method or total fluorine testing method, which are not practically available as far as I know. And then the problem with the targeted PFAS analysis comes that if you analyze 50 or 100 or 500 or 600 substances, what if the substance present is the 601, right? So those PFAS-free statements is something I would be a bit careful with.
Yes, that was my my impression as well on this. Then let's take a question about recyclability. So regarding the recyclability, does it mean that has to be already from this year now included in the declaration of compliance with reference to the old methodology?
To my understanding, yes. I'm not 100% confirmed on that, but that's, if I recall correctly, that's the situation. Yes.
Yes. Then we have a bit more specific question related to sausage casings and how to apply the PPWR. So since they since they are not seen as packaging according to the PPWR, what requirements of the PPWR do apply in this kind of case, or do they apply at all then?
To my interpretation, they don't apply at all because they are not considered packaging within the scope of PPWR. They don't apply. So it would be then whatever terms it comes to the product safety and other things would be then regulated by other things. Because it's a sausage casing, it's definitely then regulated by REACH and food contact safety regulations and things like that.
Yes. Then continuing on the recyclability topic, how will it be ensured that all packaging is recyclable? So what types of tests would be required?
That goes a bit out of my kind of area of expertise. What are the specific The different these guidelines have very detailed protocols, so Recyclability and for evergreen and all sort of things. So I would advise to visit their website to see the different protocols on how they evaluate the recyclability. But like I said in the webinar, those might not hold up as the main requirement or like the main parameters. But I think also that in the PPWR they list the things that are relevant for assessing the recyclability. But to be honest, my core expertise on the chemical testing side, as you might also say.
Yes. And from our side, we also have in our team of experts others that have more like deeper knowledge about the recyclability and those topics. So
yeah, definitely. There are colleagues that are much more seasoned on this in this area. Yeah.
Yes. So that could also be a discussion to have more directly with those people then later outside of this webinar. Then we have a question about medical packaging. About that the PPWR applies to the medical flexible packaging as well. And Anna is asking that we make a component of the packaging and are considered as a supplier. Do we have to make a test analysis for the PFAS and heavy metals? Or is the statement based on raw material supplier? Can that be sufficient?
So is it like a medical device or medical food? So
a packaging for medical device, as I understand.
Right. So then I would imagine that the PFAS requirement doesn't. Okay. So the PFAS requirement. So to clarify, that is only for food packaging. The heavy metal compliance is applicable to all types of packaging, regardless of the end use, excepting glass packaging. So it depends on the case-by-case basis. If you have enough data to show that I'm confident that this packaging as a complete product has less than the listed amount of those heavy metals, then it is completely fine to rely on supplier documentation. But if you don't have enough data to make that declaration, then you need to test the final material or the final intermediary material, depending on how much is being converted further.
Exactly. Then we have a question about the responsibilities. So how would a B2B distributor be kind of considered in the scope of who is responsible for testing and different parts?
I think that's something that maybe you need to get back to. I don't remember by heart immediately because there is definitely interpretation depending on what is your role as a distributor. Yeah, that's something that we have to get back to. Yeah.
Yes. Let's see, we can pick some questions still. We have one short question, but maybe something that is good as a clarification. So we have a question that is the 50 milligram per kilogram total fluorine threshold already an official EU compliance limit?
Yeah, it's the one listed in total. Yeah, sorry. It's the one of the limits mentioned in PPWR, and recently the Commission's interpretation of PPWR was so the draft was made available somehow. So we have seen the draft. So it's not like the official version of the interpretation yet. So I guess the answer then would be that it's not yet 100% locked down, that it's exactly like this, but the draft document says this.
Yes. Then I think we can take one last question. this is about the recycling, and we will see. This might go a little bit outside of your expertise scope, Niko, but we'll see.
Yeah, let's try.
In the chemical recycling case, would it be enough, do you think, to check the plastic waste for fluorine instead of analyzing the pyrolysis oil? So in the case of recycling plastics.
So making pyrolysis oil out of plastic waste, and then you think about doing I don't know if there's kind of some potential for concentration of the sample once the pyrolysis oil is being made. I don't know the process 100%, so I don't know exactly what's going on there. My instinct says that it's maybe no, because there's so much kind of reprocessing occurring. So it's kind of hard in my mind to kind of transfer that result onto what is in the actual oil, because there might be some trace level fluorine substances present, and which then get concentrated when that pyrolysis oil is being made. So no kind of definitive answer there.
Yes. Then I think we can start to wrap things up. We have here on the last slide the contact information to Janne, one of our sales managers. Niko will be going on parental leave. Was it starting next week already?
On April Fool's Day, yes.
Yes. So Niko will not personally be available for a few months, but you can always reach out to us either by contacting Janne here directly or getting in touch through our website, and then the right people will get back to you. Thank you everybody for participating, and I wish you a lovely continuing on the afternoon. Thank you.
Thank you everyone. Bye-bye.
Bye.